Always Believe house. And we're going to have a great day today. We're going to review the terms you learned about functions last year at junior high. We're going to talk about domain range, the input, the output. We're going to talk about what is a function and what is not a function. And we're going to find the domain, give it the range, and find the range, given the domain. Sounds like fun. So let's get cranking, okay? Before I do this, I need to start recording or I will be talking for nothing, which I've done in the past. And we are recording. A magical whiteboard appears in the office of the Always Believe house. Okay, so in this lesson here, like I said, we're talking about functions. This is a real quick review, should not be difficult. Remember, your input is your domain and your output is your range, right? This is also your x, comma, y. Okay, let me make that a little bit bigger here. So your x, comma, y, and that's your domain and your range, right? It's all alphabetical. So domain is your x coordinate, range is your y coordinate. Domain is the input, the range is the output. Okay, so really quickly on number one, this is pretty simple. Let's do number two because number two is not a function. So our domain, you put the domain from least to greatest and you only put each one once. So you put domain with a brace and my domain on number two would be 6, 12, and 18. So you put them in order from least to greatest and you only count them once. The range, you start a brace and it's going to be 1, 2, 3, 4. And this is not a function, is it? Okay, so not a function because the 12 is repeating, right? The 12 goes to the 4 and the 12 goes to the 1, right? So I would have 12, 1 and I would have 12, 4, wouldn't I? Now then, something to think about on this, put under here, put 2x plus 5, put y equals 2x plus 5. Let's do that. And let's say I put 3 in. If I put 3 in for x, I will get 11. And I'm just making this up. This is not on the worksheet here. So if I put 3 in, I get 11. What if, so that ordered pair would be 3, 11, wouldn't it? What if I had 3, 5? I could not put 3 in, get 11, and put 3 back into the same equation and get 5, could I? Or it's not a function. That's why if the x repeats, it's giving you two different answers to the input. And so it's not a function. So a function is a number that you plug in will only give you one answer, okay? So if I put 3 in, I'm not going to get two answers. So if the domain repeats, it's not a function. That's something you learned from last year. Let's go down to number 5. Now then, we're going to do this one the long way first. And let me start my calculator so we can do it with more power later on. Okay, we're going to go ahead and start. And we're going to do this. And this is kind of tedious this way. And then I'm going to show you how to do it with more power. Okay, so write down y equals 4 and replace your x with the parentheses. And let's scratch out that y and put f of x. So you would have f of negative 2, f of negative 1, f of 0. This is function of, right? And function of 2 equals, and then just do this. Okay, so what did I do to the x in these equations? All I did was replace the x with an empty parentheses, right? That's where my input will go, or my domains, right? The answers will be my range or my output. So I can change color because I got more power here. So I'm just going to plug in my domain. So in this parentheses, it'll be negative 2. This one will be negative 1, 0, 1, and 2. If we were to look at this equation, our starting number would be negative 2, and the number should grow by 4, right? 4 would be the growing number, negative 2 would be the starting number, or 4 would be my constant rate of change, and negative 2 would be my y-intercept, would it? So let's just go through and start doing these. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. 4 times negative 1 is negative 4. Negative 4 minus 2 is a negative 6. This is just 6th grade integer work. 4 times 0 is 0. 0 minus 2 is negative 2. This is my starting number in it. Okay? 4 times 1 is 4. If you minus 2, you get 2. And then 4 times 2 is 8, minus 2 is 6. Notice that the numbers are growing by 4, aren't they? As you go down, they're getting large. That's your constant rate of change. If I were to make ordered pairs with this, and you did this last year, you would have negative 2 comma negative 10, negative 1 comma negative 6, 0 comma negative 2, 2 comma 2, or 1 comma 2, sorry about that, and 2 comma 6. Those would be the order pairs, and this would graph a linear function, wouldn't it? They would go through the y-axis at negative 2, and it would go up 4 over 1, up 4 over 1. It would have a positive correlation. All this stuff you learned last year. Now then, we're going to do the next one with more power. Let's go through, and on this one right here, we're going to graph and hit Control T. Okay, so I'm going to go to my calculator. Okay, and I'm going to go to the home screen. And then I'm going to hit B graph. So hit the home screen, and then we're going to go to graph. If there's anything on your graph, delete it, okay? You can hit menu or menu actions, delete all, and that deletes everything on the graph. Now then, I'm going to go back to the worksheet and figure out what I'm going to put in. So I'm going to put in 0.1x plus 3. 0.1x plus 3. I don't need the 0 in front of there, right? So 0.1x plus 3. So 0.1x plus 3 and hit enter. I should get a line, shouldn't I? So I get a line that goes to the y-axis at 3, and it's almost flat in it because the slope is almost 0. So I have a real fat line. Now then, I need to find my domain and my range. So let's go back here. I need to know what negative 20 is. I need to know what negative 8 is. I need to know what 0 is, 3 is, and 10 is. Okay, I could use the calculator to do this. Technically, you would put these numbers in and do the math, but you could do it with more power. So let's go to here, and we're going to hit Control T. So hit the Control button and the T button, and that brings up a table, doesn't it? Now then, the first number I want to find is negative 20 in it. So I'm going to scroll up here to negative 20. And negative 20 is equal to 1. Isn't that easy? So all I got to do is go to the right number in the table, and bam, I could get my answer. So negative 20 would be 1. Now I need negative 8, don't I? So I'm going to go to my calculator. I'm going to scroll down to negative 8. And what does negative 8 equal to? It equals to 2 2/10, doesn't it? Okay, and I just did something there. I don't know what I did. Okay, there we go. So negative 8 is 2 2/10. So I'm going to go to the worksheet. Negative 8 is 2 2/10. And now I need my 0. My 0 should be 3, right? Because the 0 is the starting number. So let's scroll down to the 0. I should get 3 for 0. And 0 is 3 in it. So I'm going to go back here and put 3. Okay, this is pretty simple, right? Now then we're going to go to 3. So we're going to scroll down and we get to 3. And 3 is 3 3/10 in it. So I'm going to go to the table, 3 3/10. Now I need 10, don't I? So I'm going to go to my calculator, and I'm going to push down to 10. Do y'all see how you could get these points? And 10 would be 4, wouldn't it? That's doing it with more power. That is fun stuff. Okay, really quickly on this one, the range, you would put a brace, and your range would be negative 16, negative 6, negative 2, 2, and 6. And on this one right here, my range, remember you want to put these smallest to largest, would be 1, 2 2/10, 3, 3 3/10, and 4. And you put your domain and range in braces. You'll get better drawing the braces as you go along. Okay, I'm not going to do the next one for you. You can either graph it or plug it in. I'll set up the first one by hand. You would put this into you would do the math for this, wouldn't you? Okay, so if you were to put that in the calculator, it would give you your range. So you're just going to replace your X with your input, right? Or your domain, right? Okay, you can graph it if you want, hit Control T and get the ordered pairs, or you can plug it in either way. Same thing for number 8. You can do it either way, with the graph or with the plugging it in by hand. And now let's go down to here. Your function rule is going to be y equals mx plus b, or actually it's really in word problems it's total equals gx plus s in it. Okay, these are the same thing, okay? When you have a word problem, you usually have total equal gx plus s. That sets up a linear function. So what we got to do is we got to find the slope and then plug into mx plus b and find the b. This is how I would do it. Circle the first 2 in each one. I'm only going to do one of these for you though. Okay, now then we're going to find the slope. So m, and you're going to put 10 minus 5 over 2 minus 1, y minus y over x minus x. Excuse me. Now then we're going to subtract to get our slope, and we would get 5 over 1, which is 5, right? Now then, I would find the 2 smallest letters, so find x and y. This is how a lot of teachers teach you to write this. I could plug it into point slope, but we just need y equal mx plus b. So we're just going to get the slope, or we're going to get the function rule. So write down y equals mx plus b. And notice, this is my m, the 1 is my x, and the 5 is my y. So I'm going to replace y with 5, I'm going to replace m with 5, and I'm going to replace x with 1 and put it in a parentheses, and then I'm going to work it out, right? So 5 equals 5 plus b, and if I move over the 5, my b is going to eliminate, right? Okay, so I'm just going to get b equals 0, right? So my equation would be y equals 5x, and what do we know about this? This is k, and it's the constant of variation in it. That means that this table has direct variation, right? And if we were to cross multiply, y'all come up here, this is kind of cool. If you cross multiply, 2 times 15 is 30, 3 times 10 is 30, right? If I take this right here, 2 times 20 and 10 times 4, 2 times 20 is 40 and 4 times 10 is 20. So this table is proportional and the y-intercept would be 0, right? So the function rule would just be y equal 5x. You're going to do the same thing on 10 and 11. On number 11, if you know what you're doing, they already give you b. I'm not going to help you out on that, see if you can remember. So you find the slope, then plug into y equal mx plus b, and find your function rule. You want to write your function rule as y equal mx plus b. Let's continue on. Now then, on these problems, you are given the range, and we need to find the domain. So on these problems, you're actually given y, and you're finding x, aren't you? So you're going to replace y, and you're going to solve for x. So on this one right here, my f of x is equal to 18. I'm going to replace the f of x with 18. And now I got to solve for x, don't I? If you have a calculator, remember the rule. You would punch the 18 in first, move over the 2. 18 plus 2 is 20. You would hit enter and get the 20 and then divide by 4, right? And you would get x equals 5. And the ordered pair, if you wanted to write the ordered pair, it would be what? 5 comma 18? So when my y is 18, my x would be 5, wouldn't it? That would be kind of tricky in the table because you'd have to be looking at the y's and not the x's if you graphed it with a calculator. So y'all can finish up those 4. That is not difficult. Now then on here, remember the vertical line test. The x's cannot repeat. So if I were to draw a vertical line through this graph, it only crosses the graph once. This would be a function. I'm just going to put y. I'm going to go to one that's not. Go to this one right here. Let's draw a vertical line, and notice it crosses twice, right? This ordered pair would be 1 comma 2. This ordered pair would be 1 negative 1. Notice I cannot put 1 in an equation and get 2. Put 1 in the same equation to get negative 1, can I? The x's are repeating. You're getting 2 different answers. It won't work. So this one is not a function. So anytime the vertical line crosses twice, the x's will repeat. The graph will not be a function. Turn the page. On these right here, this is the same as above. You're going to find the slope, And then you're going to do y equals mx plus b and solve for b, right? So you need the slope and you need the y-intercept, okay? So I usually just use the first 2 points. So I'm going to use these 2 points. And let's see, the European size, y is a function of the United States size, x. So the European size is y. This is just like the star reviews. You have 2 of these problems on the bottom of the first page, same exact thing. Except I'm only asking you to find the slope. This one you got to get the function rule. So we're going to do 35.5 minus 35 over 4 minus 3.5. So I did y minus y over x minus x. I'm going to get 0.5 over 0.5, which turns into 1, right? Let me put my x and y here. Now then I'm going to write down y equal mx plus b, and I'm going to replace the y with 35. I'm going to replace the m with 1. I'm going to replace the US size with 3.5 plus b. Solve it for b. 35 equals 3.5 plus b. So my y-intercept, if I move over the 3.5 and subtract, I'll get 31.5 or 31 5/10. So that makes my function rule, y equals x. You don't have to put the 1x to you. So just x plus 31.5. Okay, so my x is my US size and my y is the European size. If I want of a US size 11 shoe, I'm just going to replace x with 11. And that would turn into 42.5 European, wouldn't it? Okay, so you're finding the slope, you're plugging into y and x plus b. It doesn't matter which one you do your x and y. I would just pick the first 2 or the first 2 that aren't negative. I'm going to let you do 23 on your own. Technically on 23, the deli worker created 8 large subs in the first 2 hours. So 0 would be 0. In the first 2 hours, he has 8. And then that's going to repeat it. And then you will finish this up on your own. What a blast. Oh, ho, ho. Stop recording. I hope you have a wonderful day today. Remember, you are amazing. You are created to do wonderful things. I hope you enjoy the moment of zen at the end of this. We all need some zen, don't we? Okay? So every lesson I'm going to give you some moment of zen from around the United States. You'll see lots of videos and just peaceful moments. Have a wonderful day, and remember to always believe.